Hi, welcome to this video session. In this video, we are going to see about the solidification definition, nucleation and directional nucleation. Solidification. It is a process of transforming the liquid to solid. During the mold, the liquid or the molten metal when cools, it releases latent heat of evaporation and it forms like a solid. In solidification, a solid phase is nucleated and grows with a crystalline structure. For the case where a solid crystalline phase does not nucleate in the cooling process, glassy structure are formed. Nucleation. Nucleation is the initial process of solidification in that occurs in the formation of crystal from a solution, a liquid or a vapor. During nucleation, a small number of ions, atoms, or molecules become arranged in a pattern like crystalline structure, and its characteristics are properties are look like or resembles like a crystalline solid. It has two types of nucleation: heterogeneous and homogeneous nucleation. If nucleation takes place in a pure liquid metal, then it is called homogeneous nucleation. If it happens when the impurities mixes with the liquid metal, then it's called as heterogeneous nucleation. This video explains the solidification of metals.
Explain the solidification of metals and alloys. First, let's discuss the solidification of metals. When we pour the molten metal in the mold cavity, we see that the solidification process starts from the sides of the mold, then moves towards the molten metal. This is because the sides of the mold provide sufficient cooling to the molten metal. After some time, we see that the molten metal solidifies in the form of randomly oriented crystals. The region where the crystals are formed acts as the production area and is called the nucleus. When the molten metal solidifies further, we see that the shape of the crystals changes to long columnar crystals. Having their axis perpendicular to the sides of the mold. Thus, the shape of the molten metal crystals formed will be as shown. Note that during solidification of metals, the temperature remains constant. This can be represented graphically as Now let's discuss the solidification of alloys. When we pour the molten alloy in the mold, we see that the solidification process takes place in the same manner as in case of solidification of metals. The only difference is that the crystals formed will have a dendritic structure as shown. Note that during solidification of alloys, the transition from liquid to solid state occurs during the change in temperature. This can be represented graphically as Thus, we can say that solidification of metal results in the formation of long columnar crystals, and solidification of alloy results in the formation of crystals having a dendritic structure.
Now, let us discuss about directional solidification. It is also a process of solidification where it follows a certain directional. For example, solidification first starts from the screw, then mold, and then it reaches to the riser. When it follows these kind of direction, it's called directional solidification. This animation explains how directional solidification happens.
What is directional solidification? Directional solidification refers to the process of producing a casting that is free from voids or shrinkage defects by feeding the molten metal into the mold. Let's now discuss how this solidification process takes place. When we pour the molten metal into the sand mold, we see that the molten metal solidifies in the mold cavity, resulting in the formation of a solid shell of specific thickness in the internal surface of the mold. The region where the solid shell exists is referred to as the solid zone. Now, above this solid zone, we see that there exists a pasty mass of metal, which is half solid and half liquid in nature. The region where this pasty mass of metal exists is referred to as the mushy zone. Now, above this mushy zone, we see that the metal exists in liquid form. The region where this liquid metal exists is referred to as the liquid zone. Let's now place our focus on the solidification process. When the molten metal solidifies in the mold cavity, we see that it creates voids inside it. These voids are filled by the liquid metal that flows from the mushy zone and liquid zone. Now, after the mold cavity solidifies, the molten metal solidifies at the riser. This step-by-step solidification from the sprue to the mold cavity and then to the riser is responsible for eliminating voids and internal cavities in the mold. Such step-by-step solidification process is known as directional solidification. Thus, we can say that directional solidification is the solidification of molten metal from the sprue to the mold cavity and then to the riser to produce a casting which is free from voids and internal cavities.
Method or factors which controls the directional solidification are the proper design and positioning of the gates and risers. Secondly, use of insulating pads and sleeves for risers. The third controlling factors are use of chills in the mold, incorporating blind riser and use of exothermic risers components are also plays the vital role to control the directional solidification. Thank you.